has said allows null values. Initial capacity of has said is 16. So initially 16 elements memory allocated. Load factor of has said is 75%. If 75% of elements are filled, then again 16 elements memory allocated. So it will not wait for 100%. After 75%, if it is filled, next again 16 elements allocated. Load factor of has said is 75%. It will allow null value. It does not allow duplicate. It is initial capacity. Here load factor 75% load factor. See here, insertion order is not preserved. Here insertion order is not preserved. So whatever we are going to enter, our order not maintained because it is unordered set. Because it is an unordered set. So order is not maintained. Because inside hashing algorithm will be there. Inside hashing algorithm will be there. According to algorithm, it works. I'll show you. These all points remember. These all points remember. Is it over? See. This program you have seen. What is the output of this program? 23, 43, 83, 56, 87, 83. Okay, as it is comes now. See, file, save. Java C demo.java. Java demo. As it is 23, 43, 83, 56, 7, 87, 83. As it is, whatever I given. Suppose if it is array list, what is output? Same output. There is no change. As it is. File, save. Compilation, execution. See 23, 43, 83, 56, 87, 53, 83. Suppose this one, if I make it as has said. This one, if I make it as has said. Now, duplicate not allowed. Here already duplicate is there. 83, 83. If you write duplicate, it is automatically ignored. Error will not come. Error will not come, ignored. So that point also write it. If we write duplicate, if we pass duplicate element, and it is ignored, so error will not come. It is ignored automatically. If we pass duplicate element and it is ignored. See, file, save. If I compile, if I execute, see, now how many elements are there? 5. 83 actually 2 times. That is not there. Ignored. And also you observe, is it my order? First what I given? 23. But what is coming? Is it my order? No. Is it ascending order? No. Is it descending order? It is hashing order. Okay. What is hashing? Algorithm is there. According to algorithm, it works. So how it works, you observe. If you write like this, now, okay, this is reference. That LL also works. HS also works. Whatever you want. Suppose I'll make it HS, 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 hasset. How it works, I'll explain. Okay, this will remove. Anyhow, that is ignored if you write duplicate. Now, file, save. Now, what's the output coming? You observe. This like this coming. Okay, this is the output coming. Just you observe this output. Actually, what is happening? You observe. Total how many elements memory allocated? Capacity 16. 16. 0, 1, 2, 3, 4, 5, 6, 7, 8. See, index. Index starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, one extra came. 16 elements only. Okay, this is, I'll remove. No. While writing, don't write this one. Because if I remove all index also removed, that diagram also removed. Now, 16 elements memory. Okay. Now, 16 elements index starts with 0, ends with 15. Now, which element inserted first? 23. What will happen is, hashing algorithm will be there. 23 modulo division 16. 23 modulo division 16. What is the reminder? 23 modulo division 16. 7. So the 23 is stored here. (23) modulo division 16. 16 1 just 16. Reminder 7. Okay. 7 place 23 stored. 43 modulo division 16. 43 modulo division 15. 43. What is that? 43? 11. 32. 16 to the 32. 11. 11 place 43 stored. Okay. Next 83. 16 5 ja 80. Reminder 83 stored here. 83 stored here. 56. 56. 16 4 16 3 ja 48. 48 plus 8. So 8. 8 place 56 stored. Next 87. 7. 7 already is there. Next 8. 8 already is there. Next 9. 87. 83, 23, 87. One is missed. 1 minute. 83 we got it properly. 23. These two changed. $83. Eight place. In between inserted here actually. Collision comes 16. Baby index 1 minute. Two. Data not shuffled, not shuffled. File, save. Java C demo.java, Java demo. 83, 23, 87, 56, 43. One minute. Actually, that algorithm should work like that only. File, save, compilation, execution. So there are actually hashing 7 algorithms will be there. See 0, 1, 2, 3, 4. Now 16, 1 is 16, remainder 4. So 20 stored here. 60, 46. 32 plus 14. 46 here. 16 to the 32. 1 place. 33. 16 1 is 16. Remainder 0. So 16 here. 96 plus 2. Here. See. 16. 33. 98. 20. 46. That collision comes no. If it is same number comes, that maybe some internal, some concept will be there. See now here 16. See this is the output we got it. 16. See 33. See 98. Next 22. 20. Last 46. Okay. And that algorithm maybe internal different will be there. Like this implemented. Like this implemented. Suppose again 32 number if I insert 32. 16 to the 32. Remainder 0. 0 already is there. So next also already is there. Next again is there. That is going to insert here. That is actual algorithm. Maybe some modifications, 7 algorithms are there. Which algorithm internally they used, we cannot predict. See now like this algorithm coming. So what will happen? 20 modulo division 16. 20 modulo division 16. What is the remainder? 4. So 20 is stored in 4th place. Okay. Next 46 modulo division 16. What is it? 14. 14 place 46 stored. 33 modulo division 16. 33 modulo division 16. 1. So we'll get a 1. Okay. Next 16. Modulo division 16. 16 modulo division 16. Remainder 0. 98 modulo division 16. Remainder 2. So 20 stored in 4th place. 46 stored in 14th place. 33 stored in 1 place. 16 stored in 0 place. 98 stored in 2 place. Like this you are getting output. Okay. Write this one. This is hashing technique. Now suppose now 1 minute you are searching for 33. Again same algorithm. 33 modulo division 16. Directly go to 33. 1 place. Suppose you are searching for 46. You are searching for 46. 46 modulo division 16. Directly it comes to 14. There only it will search. That's what very quickly. Okay. Write this one. Inserting time also, searching time also, deleting time also, that algorithm applicable. That's what fast. So like this, very quickly it will search. Is it over? So initially 16 elements memory allocated. Each number divided by 16. That index in that place it is stored. Okay, like this order. But we are calling like a insertion order is not preserved in a Java. Internally like this will be there. So internally it is maintaining order. Which order? Hashing order. Hashing technique order this is. Now if you want to search for 16, suppose if you want to search for 20, 16 the same applicable. 20 modular division 16. You will get it 4. Directly it goes to 4th. It will search. Now if you are searching for 20 also, if you are searching for 46 also, if you are searching for 98 also, 33 also, 16 also, how many iterations comes? One iteration only. That's what very quickly. Okay, same algorithm applicable. With one iteration only you did. Okay, this is hashing. Next, if collisions comes, that means that is what is happening. I'll explain. Suppose that the internal algorithm, if you are writing C program, compulsory you have to learn algorithm, but Java not required. Suppose now you are adding 16. Suppose you are adding 16, you are adding 32, you are adding 48, you are adding 64. Now what is the remainder of 16? Remainder 0. Here 16 stored. Next 32 modular division 16 0. But 0 already is there. It will shift here. 32 comes. Again if you add 48, 0 already is there. 32 already is there. So here it will store. 64. Here it will store. Because it is like this. If it is there, it will store. Like that works. So all 0 only comes, no? All 0 only comes, but 0 already filled. Next number. Next. Like that it will take. Okay. If it is C language, that algorithm also you have to learn. If algorithm also you have to learn. But Java language not required, inbuilt. You are not writing any logic. It already is there. According to that, it works. See? 16, 32, 48, 64, 80. See? All 0 only comes, no? See, file, save. If I compile, if I execute, what you're getting? Whatever I given, like that only coming, no? Like that. All 0 only comes in that situation like this. Okay. Algorithm no need to learn in Java. If it is C language, you have to learn. Now, if you are searching for 48, where it will search? 0 place. Not there. 1 place. Not there. Like that only it will search. Same algorithm concept applicable. Okay. Remainder 17 comes, memory allocated again 0. That is algorithm you have to learn. 7 algorithms are there. 1 week it will take to understand. That is C language data structure class you learn. You are not required because asset class already prepared. Okay. Next, linked asset. Next heading, linked asset. Linked asset. It is an implementation of hashing technique with linked representation. It is an implementation of hashing technique, linked representation. Linked asset. It is an implementation of hashing technique with linked representation. Hashing again, no need to write. Linked asset does not allow duplicate elements because it implements set interface. Same. Linked asset allows null values. Linked asset does not allow duplicate elements because it implements set interface. Linked asset allows null values. Linked asset occupies more memory because data stored in nodes. Linked asset occupies more memory because data stored in nodes. Who is this person? Like 17. Reminder how 17 will come first of all. Divisible, no? 16 divisible. 16, if it is there, divisible. Again, what will happen? 1 comes. Now, linked asset occupies more memory because data stored in nodes. If 75% if it is filled, next 16 elements memory allocated. That is, you can add 16 plus 1, 17. Like that, you can do it. Okay. Linked asset occupies more memory because data stored in nodes. In linked asset, insertion order is preserved. Because it is an order set. In linked asset, insertion order is preserved because it is an ordered set. Linked asset is an ordered set. I think you are not listening class. How to search already told. Same insert also, delete also, search also, same technique applicable. That's what hashing definition also I given. See, first point, what is the difference between hash set, linked asset? Hash set is array representation. Here, linked representation. This is second point is same. It does not allow duplicate, that will not allow duplicate because set interface. Third point, same. There also null value allowed, here also null value allowed. Linked asset occupies more memory because data stored in nodes. In linked asset, insertion order is preserved because it is an ordered set. That is unordered set, this is ordered set. That is unordered set, this is ordered set. Right, is all? Is it over? See. Java.util.linked asset. Linked asset. If you open. Forty-eight number if you want to search. 48 modulo division 16. What is the reminder? 48 modulo division 16. Reminder is 0 place it will search. Not there. 1 place. Not there. That is only searching. See, linked asset. Here, see, constructs a new empty linked acid with a default initial capacity 16, load factor 0.75. 0.75 nothing but 75%. So it is also same. Write it. Here also initial capacity of linked is, here also initial capacity is 16. Here also load factor is 75%. Here also load factor is 75%. Here also initial capacity is 16. So here, what is the difference you observe? One is linked representation. One is it will occupy more memory. One is ordered. That is unordered. That order we cannot predict. That is based on algorithm we can predict. But this is ordered. My order is maintained. You observe. Program also written on acid. Now linked acid. See what we have tried. See, just linked. Here linked. Here this is same also works. That is reference. Otherwise another reference. See, file, save, compilation, execution. See my order. Okay, this is I given same. That is acid also comes same. Suppose. Now file, save, compilation, execution. See my order maintained 56, 22, 58, 74, 10. Whatever I given, that order comes. Write this one example. This is ordered set. That is unordered set. This is ordered set. That is unordered set. This is ordered set. That is unordered set. But what is the difference between array list and hash set, linked hash set? Give me answers. Hash set is differences. Array representation. This is linked representation. That is one difference. Next, memory. That will occupy less memory. This will occupy why more memory? Nodes. You have seen linked list. Three parts. That's what triple memory required. What is third difference? That is unordered set. This is ordered set. These are the differences. Okay. Now, next one, tree set. After completion of tree set, three differences I'll give at a time. All sets. Tree set. It is an implementation of binary search tree technique. With linked representation. It is an implementation of binary search tree technique with linked representation. So name is tree set, but it is linked only. It is linked representation only. First, what is binary search tree technique? You studied unary operator, binary operator, ternary operator. What's the difference? Only one operand is there, unary. Two operands are there, binary. Three operands are there, like that. Here binary nothing but maximum 2 child nodes. That is binary. Search tree. Why it is called search tree, I'll explain. A binary tree is said to be binary search tree if it is follows the following rules. A binary tree is said to be binary search tree if it is follows the following rules. First rule, if the element is less than root element, then it must be in left subtree. If the element is greater than root element, then it must be in right subtree. If the element is less than root element, then it must be left subtree. If the element is less than root element, then it must be in left subtree. If the element is greater than root element, then it must be in right subtree. A binary tree is said to be binary search tree if it is follows the following rules. If the element is less than root element, then it must be in left subtree. If the element is greater than root element, then it must be in right subtree. So in a tree, left to right, if the element is less than the root element, then it must be in left subtree. If the element is greater than root element, then it must be in right subtree. If it follows like this, that is called binary search tree. Suppose if the element is same, if the element is less than root element, left side. The element is greater than root element, right side. But if the element is same, you are selecting one answer. You are not thinking. It is set. Will it allow duplicate? but you are giving left to right like that. You have to think, no? So it is set. It will not allow duplicate. Same element not possible. Same element will not allow, no? If I ask question, you are selecting one answer. Left or right, like. See, same element not allowed. Duplicate not allowed because set. Write it. Tree set does not allow duplicates because it implements set interface. Tree set does not allow null values. Tree set does not allow null values. Null values not allowed. See, array list, linked list, asset, linked asset, allowed. This one not allowed. Does not allow null values. Tree set does not allow duplicate elements because it implements set interface. Tree set does not allow null values. Here, all elements are sorted because it is a sorted set. It is a sorted set. That is unordered, ordered, sorted. Three sets. Unordered set, ordered set, sorted set. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. So here nodes, here what will happen when element comes, then only memory allocated. That's what no initial capacity, no load factor for this. This is also red block tree also we can call. They given binary tree, binary search tree, red black tree, like that also is there. There are so many trees concepts in data structures. AVL tree, heap tree, binary search tree, B plus trees, red black trees, so many trees concepts. That is data structures is one subject. Almost it will take 75 days. That is also on course. But here, predefined data structures, you are learning. That's what within a 1 week it will finish. But these all, if you want to implement your own, it will take minimum 2.5 months, 3 months it will take. That is also. Only this topic also 2.5 separate course is there. In our institute also is there. Data structures using C language is there, C++ is there, Java is there. That is separate course. But here what you are learning? Creating object calling method. Are you writing any logic? No. That is more logical part. Data structures. Okay. In your academic also is there, no? Data structure using C. Data structure using C++. Data structure using Java. Data structure is a concept. You can implement in any language. C also, C++ also, Java also, Python also, C# also. Okay. See, it is linked as said. Like that only, tree set. Tree set. If you open tree set, see here constructs a new empty tree set sorted according to the natural ordering. It is elements. See, no initial capacity. So no initial capacity, no load factor. So according to that only, when element comes, memory allocated, then only inserted. Okay. See how it works. Suppose, see here, tree set, integer, TS equal to new tree set. TS dot add one element. TS dot add one more element. TS dot add one element. TS dot add one more element. TS dot add one more element. TS dot add one more element. If I write like this, system dot out dot println TS. Suppose if it is has set, what is the output? If it is has set, we cannot predict that algorithm required. If it is has set, we cannot predict. With the algorithm only we can give answer. Okay, that's what unordered set. Linked as set, say my order. Tree set, sorted. See, file, save. See, compilation, execution. You are getting like this. Now, how you are getting, just you observe. The sorting, how it is coming, you observe. Actually, what will happen? First of all, okay, this is 1 minute. For web development, data structure not required. See, 83. First 83 stored here. First 83 stored as a root. As a root, 83 stored. Now, next to 45. 45 less than 83 or greater than 83? Less than 83. Then left side. Then left side. Here 45. This address placed here. Okay. Next 89 greater than 83. So right side. Right side 89. Now like this. Next 23. 23 greater less than 83 left side. 23 less than 45 left side. Like this. 23. This is placed here. 98. 98 greater than 83 right side. 98 greater than 89 right side. $98. Next 92. 92 greater than 83 right side. 92 greater than 89 right side. 92 less than 98 left side. Suppose you take any one number randomly. Suppose you take any other number randomly. Suppose 56. 56 less than 83 right side, left side. 56 greater than 45 right side. Like that inserts. Now after this, you observe 23, 45, 83, 89, 92, 98. It is ascending order. Ascending order, you know. 23, 45, 83, 89, 92. It is sorted, no? It is sorted, no? Like this coming. This is the output. ನೋಡು tree set. So has set, linked as set, tree set, three sets. So actually these diagrams also not required because you are not writing any algorithm, you are not writing any logic. Concepts required in Java. While learning data structures course, algorithm required, implementation required, everything required. So all elements are sorted. That's what it is called, sorted set. Is it over? So first it will compare with root element, less than left side. Again left child element also it will compare. Again less than left side, not there, greater than right side. Same element will not come because it is set. Set does not allow duplicates. Same element will not come. Okay. Next node on. Is it over? Now, differences between has set, linked as set, and tree set. Differences between has set, linked as set, and tree set. One side has set, one more linked as set, one more tree set. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with linked representation. It is an implementation of binary search tree technique with linked representation. So name is tree set. That is linked tree set only. Linked representation. Trees generally they won't use array representation. It will occupy more memory with the trees. That is again I have to explain what exactly tree. It will take more time. Say that is based on index will stored. It is stored. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with linked representation. It is an implementation of binary search tree technique with linked representation. Which one occupies less memory? Which one occupies more memory? Hash set, less memory. Linked hash set, tree set. Tree set also linked tree only. So more memory only. Write it. It occupies less memory. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. It is ordered set or unordered set or sorted set. It is an unordered set. It is an ordered set. It is sorted set. It allows null value. It allows null value. It does not allow null value. Okay. So these are the differences between hash set, linked hash set, tree set. Up to here, sets completed. Tomorrow, maps. Hash map, linked hash map, tree map. Has set, linked as set, tree set. Is it over? We'll see continuation tomorrow. Hash map, linked hash map, tree map. Ascending order. Descending order, more utility collections are there. With that, we can do it. Now, tree set is sorted set. So, automatically ascending order comes. If you want to make it descending order, separate more utility collections are there. Collections, one class is there. With that, we can make it. Okay, I'll upload. We'll see continuation tomorrow. (17) index only. We have to add 0 plus 16. Like that. 0 plus 16. Next time 32 plus 0. Like that we have to add. We'll see continuation tomorrow.